Hello all, today we're going to do a circuit that changes sound to light, like you get in discos where somebody shouts and the light comes on, or the lights flash in time to the beat. So how do we go about designing a circuit? Now that sounds a far more exciting circuit than all the circuits you get in the final papers of the November exam. So let's call it a sound to light circuit. Now, what's the first thing we need in almost any circuit is we need a battery. I always draw the long side or positive on top because the voltage is rising from naught or the negative side of the battery, and it is rising up. So here it is plus 5 and here it is 0 volts. Or 5 or 6 volts. Now we need something that is going to flash. We could use our classical light bulb, but that is just so 20th century. We're not going to use light bulbs anymore, folks. The syllabus must get with the program. We're going to use an LED. Now you know the symbol for an LED is a triangle, but in which direction does the triangle point? Well, conventional current is in that direction, so the triangle must point in the same direction as conventional current. You see, it looks like an arrowhead. That's the direction that our conventional current, which is from positive to negative, goes. So here's our light emitting diode. It's going to give off light every time there's a beat. But every semiconductor, like a diode or transistor, needs some protection to stop runaway current, because it either switches on or off. It's got no real resistance. What is the thing we're going to need to protect our LED? We always have a resistance of about 400 ohms. Can be 200, can be 180, but just as long as we've got a couple of 100 ohms resistor. Then we come to our exciting, I find transistors, they're just so old. I mean, they've been around since the Second World War. But they're such exciting little components, very cheap, but they do a lot. They're like little switches. They have the symbol of a circle. You have your collector. It goes to a thing called a base. There's your base. And here with a little arrow is our emitter. So the current is going to come from here if the base will allow it, and the base has got to be positive. It's all about the base. The base has got to be positive if you've got an NPN transistor. The middle one tells you what the base has got to be positive. You also get PNP transistors where the base has got to be negative. But this is an NPN transistor, a BC247. Right, now the current comes out of here and then it completes the circuit. But now there's nothing here that's going to respond to sound. So we're going to, first of all, add something that will bias the base so that this light is just about to come on. And if you were watching our video, our last one, number 10, the thing that we use is this device, a potentiometer. It's something that's attached to the positive, it's attached to the negative. I hope you can see this whole circuit. It's attached to the positive side, attached to the negative, and our sweeper goes to the base. So we can move this up or down. We can make it more positive by moving it up, more negative by moving it down, but in fact we use a little thing that turns. It comes in a circle and it's a potentiometer. It will give us a voltage that just biases this transistor open. Now normally a transistor just needs about 0.6 volts, and then it'll start to turn this into like an open switch, into a closed switch. And it'll allow current to flow through and our LED will come on. So we need this potentiometer to just bias the base so it's about to come on, and then we do a very exciting thing. We put a device between here, and that is a microphone. So there is the symbol for a microphone. I just can't remember whether that goes there. I think it must be there. Otherwise you wouldn't see it. So that is our microphone. Now, this is actually a condenser microphone. So when you speak onto the microphone, it's got, this side is charged positively, this side is charged naught or negatively. And when you speak, it pushes the condenser closer to, so that the positive and negative sides of the microphone come closer together. And as it does, the positive and negative charges interact and chase each other around. Because as you bring positive and negative closer together, it wants to pull the charges more, because positive attracts negative. So this will change the bias of our bass. So when we have sound waves coming, there's lips. Okay, there's a nose, there's an eye. So when you blow on this or speak to the speaker, it's going to bias this, which is, it's going to bias it totally positive or totally negative. Whereas it was just on the point of coming on, this microphone tips it over and makes it come on, come off, come on, come off every time you have a loud noise. And then this light will also glow or come on in time to the microphones, being the loud sound reaching the microphone. So the microphone will just add to the bass that extra little bit to make the light come on fully. Have a look at the circuit now, we'll show you how it works. So here's our little circuit. It's on a breadboard. Here is the LED. Now here is our potentiometer. And we can watch the LED, we can make it glow. Right, so here with our potentiometer, we can turn it on to very bright, or we can turn it dim, brighter. Now let's just get it so that it's almost off. Now, when I blow onto the microphone, or if I drop and make a noise, watch how, you see how it gets brighter. So here's our cute little circuit that changes sound into light.